I should put this last slide as part of our last one because I forgot to deal with animal wastewater. But we do have a lot of waste from our CAFOs, our concentrated animal feeding operations. And that can contain digested animal food, hormones, antibiotics, things like that. The way this is dealt with is what's called a manure lagoon. It's a large human-made pond lined with rubber to prevent the manure from leaking into groundwater. It's broken down by bacteria, and then it can be used as fertilizer. The dangers that we have, these could leak, they could overflow. The runoff that's used as fertilizer can run off and pollute water. So we know from those large CAFOs that we need to deal with all that large quantity of manure. Heavy metals and other substances, the ones we're going to highlight here, the ones that we're concerned with are lead, arsenic, mercury, acids, and then into synthetic compounds. All right, so we're going to take a look first at the heavy metals. First one is lead. Lead contaminates water when it passes through old pipes, and it can damage the brain, the nervous system, and the kidneys. In the mid-1990s, about 10% of the municipal water supplies contained lead levels that exceeded the maximum permitted by the Safe Drinking Water Act. Arsenic occurs naturally in the Earth's crust and can dissolve in groundwater. Mining adds to arsenic by breaking up rocks. And arsenic is also used as a preservative for wood. It can be removed by fine membrane filtration, so we can just filter it out. And it causes cancer of the skin, lungs, kidneys, and bladder. There's many people that suffer from arsenic poisoning, and they have no other options. They have no other way to deal with removing that arsenic. Mercury. There's an image there that with the mercury releases from different regions of the world. 54% of our mercury is from Asia. It comes from burning fossil fuels, especially coal. The incineration of garbage, hazardous waste, medical and dental supplies, and cement are all contributors of mercury. It makes its way into water, and mercury itself is not bad, but once it becomes combined with organic things like methylmercury, that's very, very, very toxic, even in low doses. It damages the central nervous system, and we're concerned with our exposure because it's in fish and shellfish, and it makes its way up the food chain. So the higher the organism, like tuna, the more that it's in that organism. Now we're going to move on to acid deposition, which is essentially acid rain or acid snow, and acid mine drainage. So burning coal is bad. It releases sulfur dioxide and nitrogen dioxide, so SO2 and NO2, which then make sulfuric acid, when it combines with water, H2SO4, and nitric acid, HNO3. And it's returned to Earth as acid deposition, rain or snow. It reduces the pH below 5, which is fatal to aquatic organisms. And we can have things like coal scrubbers. So coal scrubbers pass the hot gases that are leaving the coal plant through limestone, which reacts with these acidic gases. So it can scrub some of that SO2 and NO2 out of the smoke, through the smokestack. Abandoned underground mines, coal mines, can flood, and the pyrite that's in them will break down and produce iron and acidic and low pH water. Same with mountaintop removal. It'll unearth things like zinc and copper and aluminum and manganese, and it'll help make the pH low. And so that contributes to acid rain. If we're looking at synthetic organisms or synthetic organic compounds, we're looking at a couple of different categories. Okay, so the 4 categories, the first one is pesticides and inert ingredients. So pesticides and things that are inert. There's 3 main concerns of synthetic pesticides. One is that the pesticides do not target a particular species of organisms, but generally kill a wide variety of related organisms. 2 is that pesticides designed specifically to target a particular aspect of a pest species' physiology can also alter other physiological functions. So this is sort of like pharmaceutical side effects. We're trying to target one thing, but other things can happen. And 3, we can have inert ingredients. So additives that make a pesticide more effective, allow it to dissolve. They are often things that are trade secrets, and we don't know what they are, can be fatal. Roundup has an inert ingredient that we don't know what it is, that is bad for amphibians. Our second one is pharmaceuticals and hormones. Antibiotics, reproductive hormones, non-prescription drugs, steroids, Hormones, we only need very low levels for them to cause problems. They end up in our water. Military compounds, perchlorates, which are rocket fuel, are easily leached. They persist in the environment. They contaminate food. They affect our thyroid gland. And then industrial compounds, chemicals used in manufacturing. There was a river in Ohio that caught fire more than once because they just released industrial compounds into it and made it flammable. PCBs are one of them, polychlorinated biphenyls, which are used to make plastic. They were banned in 1979, but they have a long-term persistence, and they're both lethal and carcinogenic. The concern that we have now is PBDEs, polybrominated diphenyl ethers, which are flame retardants. These flame retardants are showing up in fish, birds, and human breast milk, and they can cause brain damage, and we don't have any bans on them yet. Moving on to oil pollution. So oil pollution, how does it happen? There's leaks, especially from offshore platforms. Examples are things like Deepwater Horizon or looking at the Exxon Valdez. Remediation for 20 years. The bald eagles and the salmon are okay, but the killer whales and the sea otters are not. There's oil still in the environment, and it has made a move that new ships need to have a double hull, a lining to keep in case this were to happen again. When we look at remediation, there's 4 ways to remediate. The first one is mammals and birds just need to be cleaned by hand. There's nothing else that we can do there. 2 is surface oil. Surface oil, we can contain it and suction it off. We can use a boom to sort of surround that in. We can apply chemicals to allow it to break up before it hits the shore. We can use genetically engineered bacteria. 3, there's no way to really address underwater plumes other than trying to cap them. Deepwater Horizon sort of taught us that. Or there's natural underwater plumes that we just don't address. And 4, rocky coasts. High pressure hot water is what was used in Alaska, but that removed and killed plants and animals because you're essentially spraying boiling water on them. So there's no best way to respond there either. Looking at non-chemical pollutants, we have a couple: solid waste, sediment, thermal, and noise. Let's look at them each in a little bit of detail. Solid waste pollution is garbage. It's mostly from landfills, but can end up in our water. The Great Pacific Garbage Patch, which is the size of Texas. There's garbage on beaches. It's dangerous. Cruise ships were dumping ships. We started to become concerned with this when medical waste was being washed up on the beaches in the 1980s. I remember this growing up, syringes and things. Coal ash or coal slag, which is what's left over after coal is burned, contains mercury, arsenic, and lead. It's not really regulated. We sort of dump that wherever we want. So that causes problems and can pollute water. Sediment pollution. Sediment, particles of sand, silt, or clay is carried in moving water and drops. And when the flow slows, that's the sediment goes there. So it's increased by construction or plowing fields. It makes the water cloudy, which decreases the light, which can clog gills or not allow for photosynthesis to occur. Thermal pollution is a big deal. It's heat. It causes substantial change in the temperature of water. Usually cold water is removed to use in these cooling towers, but then a lot of times the heated water is returned, things from industry or power plants. So it's clean water, but it's warm. It can cause thermal shock, can kill or cause increased respiration because it has less dissolved oxygen in it. It can just shock and kill fish. And then we have noise pollution. Sounds from ships and submarines can interrupt the sonar of organisms like whales. We do have some ways to deal with this. We have some water laws. The first one is the Clean Water Act of 1972. It was the protection and propagation of fish, shellfish, and wildlife and recreation in and on the water by maintaining and, when necessary, restoring the chemical, physical, and biological properties of natural waters. It doesn't include groundwater. It issued water quality standards that defined acceptable limits of various pollutants, and the EPA can set permits. Our other one is the Safe Drinking Water Act, which started in 1974 and was revised in 86 and then again in 96, which sets the national standards for safe drinking water. The EPA establishes the maximum contaminant levels, the MCL. We looked at this when we did our water quality study, for 77 different things. It's somewhat subjective and subject to political pressure. So these are some of the things that you can look at, and you can see what the maximum contaminant level can be, the parts per billion. In the developing world, Things are polluted during industrialization, and they're now addressing the problem. Developing countries have less restrictive environmental laws and little to no wastewater treatment. So as much as we can do, we still are dealing with countries that are going through the same phases that we went through. We can see that we still have work to do. We still have, what our problems are with streams and rivers and lakes and ponds and reservoirs and bays and estuaries. So we still have a long way to go, but we've made some strides in improving our water quality. We have to take into account that water is a global resource, and so us dealing with our water problems, but we also have other countries that need to deal with their water problems.